Welcome to Brain Vision.
We need to find the forces exerted at the point D and the point F due to the force of 45 kilonewtons acting at the point G. So to start solving this problem, we're going to first take the moments, the sum of moments about the point A, and set it equal to 0. And we can write that as 45 times 55 minus b of y times 110 is equal to 0. And we can take this equation and solve it for b of y. And that will give us a value of 22.5 kilonewtons. And since this system is in equilibrium, this y component at the b point, this y component of the force has to be equal to the y component at the point A. So we can say that a of y is equal to b of y. So a of y will also be equal to 22.5 kilonewtons. So now we can take the moments, the sum of moments about the point G. So the sum of moments about the point G is equal to 0. And we can write that as a of y times 55 minus a of x times 22 is equal to 0. And we can plug in the known terms and solve for a of x. So we're going to have 22.5 times 55 minus a of x times 22 is equal to 0. And we take this equation and solve it for a of x. So we'll get a of x is equal to 56.25 kilonewtons. So the force, okay, so again, going back to the free body diagram. So at the tong ADF, we know that the force exerted at point F, the y component of the force, is going to be equal to the opposite of the y component at the point A, since that's the only force acting in the y direction on this tong. So we can say that a of y is going to be equal to negative f of y. So we can say that f of y is going to be equal to negative 22.5 kilonewtons. So now we're going to take the moments about the point F. So the sum of moments about the point F is equal to 0. And we can write that as the force at point D times 75 minus a of y times 100 minus a of x times 160 is equal to 0. And one thing about this free body diagram, so C and D are members of two forces. So we can say that the force exerted at point C due to point D is equal to the force exerted at point D due to the force at point C. So using this equation and plugging in the known terms, we get that D times 75 minus a of y times 100 minus A of x times 160 is equal to 0. And solving this for d, we get a force of 150 kilonewtons that is going in the left direction. So next we can solve for the x component of the force at point F. So to do that, we can say that the sum of forces in the x direction is equal to 0. And this is going to look like A of x minus the force d plus F of x is equal to 0. And we can plug in the known terms. Set it equal to 0 and solve for the unknown F of x. So we get that F of x is equal to 93.75 newtons. So we know the y component, and we also know the x component. So we can solve for the magnitude of that force. So F is going to be equal to the square root of the x component squared, plus the y component squared. And this will give us a force of 96.4 kilonewtons. And to solve for the direction of the force, we say that theta is equal to the tangent inverse of the y component divided by the x component. And this will give us an angle of 13.5 degrees. So we can now say that the force is equal to 96.4 kilonewtons in the downwards direction at an angle of 13.5 degrees.